Okay, let's do another example of multiplying and dividing. This is example 2b. Once again with some new functions here. Let's do f of x equals 3x minus 2. And g of x is x squared plus 1. Same directions again. Let's find f times g of x and also f divided by g and our domain also for each one. My first, the multiplying f times g of x, take function f is 3x minus 2. Times function g x squared plus 1. And I have a binomial times another binomial. FOIL this out. 3x times x squared is 3x cubed plus 3x minus 2x squared minus 2. Now rewrite this so it's in standard form. Highest power to lowest power. And there's my function multiplication, f times g of x. As far as our domain for this one, is there a number that we couldn't plug in for x? I can take any number and cube it, any number squared, any number times 3, that's okay. My domain is all real numbers. Okay, g of x, or f divided by g of x, I should say. Function f is 3x minus 2. Function g is x squared plus 1. Okay, in this case, let's think about simplifying. X squared plus 1, the only way we could factor that is if we use imaginary numbers. 3x minus 2, we can't factor that anymore. I can't simplify this at all. That's all we have to do. And sometimes it's that easy. I guess I don't know if it's really any easier or harder, because sometimes when that's all you can do, you feel like you should be able to do something more, but that's it. Now let's think domain here. Is there a number that would cause a problem? And usually when I see a fraction, first place I look is the denominator, when the denominator would equal 0. And in this case, since it's x squared plus 1, my denominator is never going to equal 0. Because whatever x is, I square it, that's positive. Add 1, it's going to be positive. Even if x is 0, 0 squared plus 1 is still 1. We don't have any issues. So our domain here is also all real numbers.